All right, now we're streaming. Sorry you missed the first 5 minutes, whoever's watching this online. Thank you. Okay, the majority of what we'll be talking about today is going to apply to Jeopardy-style CTFs, because that is the most popular and the most common. So, when you are competing in a Jeopardy-style CTF, there are a bunch of categories of the types of questions you'll be presented with. They usually contain these categories, but they aren't limited to these categories, or you might not always see all of them. Big ones are cryptography, web security, reverse engineering, binary exploitation, digital forensics, open source intelligence, and sometimes there's a miscellaneous category. And they're often shortened to these acronyms or just shortened words. So starting with cryptography. Cryptography is essentially when you look at how to encode messages in a way that makes it very hard to decode it unless you have a key. So there's different types of objectives when you have a cryptography question, and it really depends on the type of cryptography that they're using. A lot of the easier questions are going to use pre-modern types of encryption. So you can think of this as a Caesar cipher, where every letter is shifted 13 letters down the alphabet, or a XOR cipher, where every letter is XORed, or a Vigenère cipher, which I can't remember what it does, but is slightly more complicated, but still pretty easy. Up until the 1950s, these were the main methods of encrypting data, making it hard for others to read, is some sort of substitution or transformation that moved the letters around in a sort of predictable way. However, about in the 1950s, Shannon wrote a paper and discussed the possibility of perfect security in your ciphers, which led to new cryptographic methods such as AES, Diffie-Hellman, RSA, and these are the types of ciphers or encryption methods that are used in pretty much every form of modern-day computing. So when you make a connection to a website, it's going to be using some form of a modern encryption that is very hard. In fact, it's called computationally difficult to break. So challenges that are based off of modern ciphers are often not break the AES cipher, because then if you did that, you would have a prize and you'd become a well-known computer scientist. Rather, it's someone implemented AES this way. It's implemented incorrectly. Break this implementation. So, oftentimes I found that when you do when you're doing a more modern type of cryptographic problem, it's going to require you to do a lot of math and to read a lot of like scientific or computer science research papers that someone found a vulnerability in one of these implementations. They're really fun if you like math. I don't like these questions personally, but there's a lot of tools and resources you can do if this is something that's types of challenges that you'll enjoy. Sage is a Python library that essentially has a bunch of pre-made functions in Python that allow you to construct different cryptographic things, matrices. You can implement AES in this. You can already have an implementation of AES. Essentially, it lets you do anything you want inside the cyber or cryptography world with ease in Python, which is always a plus. On top of that, if you're trying to do a basic encryption or like encode or decode, CyberChef is great. This tool has a bunch of encryption and decryption methods already in. So say we have a base 64 string, you can just put that base 64 string in the input, put this in the recipe, and then it will output. So it just created a base 64 text for me. Other tools you have are Python. Python has its own cryptography library that's pretty solid. If you've ever taken discrete math, that's going to help you in your ability to understand what's going on. Or if you've taken pretty much any of our cybersecurity courses at the junior or senior level, the first 4 weeks are usually just going over what encryption and decryption and different types of encryption and decryption are. So you'll have that drilled into your head as well, which will give you some foundational knowledge. Last, CryptoPals is a place for you to practice these types of challenges. So if we go to CryptoPals, We can do this problem ourselves, actually. It's asking us to take this string, which is just a random string they gave us, and convert it into base 64. Base 64, for anyone that doesn't know, is essentially a way of encoding data into another form. So what it does is we have our alphabet, which you could consider as like base 26, or binary, which is base 2. In base 64, you have 64 different types of characters that it could be using when it makes that encoding mechanism. So all we have to do is figure out how base 64 works, take this string, and put it into that program. But I'm lazy, and Python already tells us how it works, which means all we really have to do is, let me show you our demo. If it would work. So we have this function that I wrote in Python that essentially says, take a user string as input and then convert it using a base 64 library in Python to base 64. That's this line. And then print it out. Super easy. So all you do is Python and the program name, and then hello world. And then there's your base 64 encode decode. Easy as that. You can write it yourself and see if you want to figure out exactly how base 64 works. But that's the first challenge complete in CryptoPals. There's a whole ton of questions that go from the basics all the way to abstract algebra. Do as much as you like, but this is a way you can practice them. Next. Any questions about cryptography before I move on? Cool. Another category that is very common in CTFs is web security. Web security is essentially getting a website, URL, address, whatever, and finding a vulnerability in it and then finding a way to exploit that vulnerability so you can capture the flag or get whatever necessary data you need. Oftentimes you'll find vulnerabilities such as cross-site scripting, SQL injection, improper authorization, cross-site request forgery. There's a ton of different web vulnerabilities because websites were not properly designed. The web in general is not properly designed, so it makes it super easy for hackers to get around and do whatever they want. There's a lot of tools that you can use. The big one that's used by a lot of people is called Burp Suite. Essentially what it does is it takes your request that you send to the website server, and before it gets sent out of your computer, it'll capture it, let you look at it, edit it, change it, just send it a bunch of times with random edits, which allows you to do whatever you want with the data that you're requesting from the website that you're working with. Other tools are the browser developer tools. So if I go into Firefox or Chrome and I do open inspect source or look at the inspect page for, let's do this one. Where'd it go? So if I just do Control I on, this is a version of Chrome. Maybe it's not Control I. Someone, oh, right click. View, inspect. So if I just inspect, this is your developer console. Normally you're only going to look at the elements, but there's also a really powerful network, which anytime you make a request, it'll show you all that's going into that request and everything that's going over the network. You can also go into the console, make console commands in JavaScript, write your own JavaScript as needed. So the in general, the console and viewing the source is a very powerful way of looking at a website and trying to find vulnerabilities.
Wait, you can go into the console for a website that you haven't created?
So it's server-side website. You're not going to be able to send commands to the server, but you can write your own client-side JavaScript if you want inside of the console. Mm-hmm. Other tools are Python's request library, which is another way to automate any requests you want to send to the server. You can just, again, capture the request that's being sent, copy paste it, and then write a Python script to change whatever variable you need inside of a request. And then last is Juice Shop, which is a really good way to practice web vulnerabilities. It's developed by a company called OWASP. They put out a lot of stuff on vulnerabilities for websites, including OWASP Top 10, which is their list of like the most important vulnerabilities in websites over the last couple of years. But JuiceShop is essentially a website that they designed that is intentionally vulnerable, that has a bunch of goals for you to exploit, and like little rewards if you're able to write your own exploits and hack their website correctly. You can just download it and host it yourself on like localhost or something, or a Docker machine or something like that. I think there's other websites that host it too, but that gets kind of cluttered and messed up. But if you're looking for a way to just really grind and dive into how to hack websites, JuiceShop is a good starting point. There's tons of resources online explaining how to solve all the different challenges and to learn more about what the challenges actually entail. So let's do a little demo on web security. If you're already signed into our CTF, this is great for you because it's one of the CTF challenges, and you might just get a free flag. If we go to our CTF War Games and do web path to victory, go to that website, which we were already at, we'll see this website, which appears to be normal at first. There's some sort of contact we can fill out. See if that does anything. No, looks like the send button doesn't do anything at all. Great. Okay, so when I'm looking at this first, I see a pretty glaring issue, and that is in the top of the URL, there is a files directory inside the URL, which is making me think that maybe we're able to access parts of this website's URL structure that we're not supposed to. Because if you've ever like set up your own website, you should know that a website is essentially just taking a directory or a folder on your Linux machine and then making that publicly available for anyone to view. So if you give them the wrong folders to make publicly available, then you're able to access more of their machine. So think about your own machine and your own folders than they intended for you to access. So let's go down the directory structure. What happens if we do /dir? Nothing. Okay. Let's go to just /files. That's new. We're now seeing a directory. Is there anything in directory? No, that's the same thing. Cool. So what happens if we go to just /webpage? Oh, that's not supposed to be there. We're not supposed to be able to see that. We're looking at session keys. What's in the session keys? That looks very interesting. There's your flag. So this is essentially a very common vulnerability where path traversal is allowed when it shouldn't be. It's a very easy setting that should be on by default, but sometimes it's not on by default whenever you're setting up your server. So if you ever want to, if you just want to do that anytime, there's a free flag for you to look at. All right, next, before I move on, are there any more questions about web security as a CTF challenge? All right. Where is it? There it is. Next category is reverse engineering. Reverse engineering is essentially being given a file, given anything that runs on a computer, and you're asked to understand a certain aspect of it without having the source code. So you can think of being given a C executable and asked, hey, this is checking for a password. Tell me what the password is by looking at the executable you're given. Sounds very hard, but oftentimes it's easier in practice than it sounds. Sometimes it's not. Sometimes it's very hard. So there's a lot of tools to do this. The first thing you should always do is run strings. Strings, what it does, it's a Linux program in the terminal where if you run strings on a file, it'll tell you every readable string that is located in that file. So when you have a normal executable, it's a bunch of zeros and ones, but it'll still have strings in there. Like if it's printing hello world, you'll be able to see that string in there. You'll be able to see strings about what functions it has. There's a lot of strings. There's also a lot of garbage in there that it interprets as strings, but you should be able to read through it. There's also strace, which that will look through the list of calls that a function or that a program is being made. So every time a program runs, it will it'll make calls to the kernel and say, hey, I want to run this function that gives me this property, or I want to run this function that gives me this property. It'll just give you a list of all those calls that are being made while it's running. And then there's two very common tools that I like to use. The first one is GDB. Has anyone used GDB just in general for debugging? A couple people. So GDB is a C debugger on the terminal. If I were to, I don't have a normal version of GDB. I'll show you later. Essentially, what GDB does is when you're writing your C program and you're wanting to debug it, but alas, you don't have a IDE, you're using Emacs or Vim and you need to debug a program, you use GDB, which will do the same thing that your VS Code or your Visual Studio ++ or whatever it's called will do, code blocks. It'll do the same thing where it sets breakpoints, it runs you through the breakpoints, you can see the code that's running, but it doesn't just do it for source code. It'll also show you the instructions and the assembly that it's running. You can set breakpoints in the assembly as well, which allows you to see what the computer is doing while it's running in the command line. If you want to see what's going on while it's not running statically, then you'll use a decompiler such as Ghidra, IdaPro, or Binary Ninja. They all do fairly the same thing. IdaPro is probably the best, but it's also $6,000. So yeah, don't use that unless you just want to blow a bunch of cash. Binary Ninja and Ghidra are free. Ghidra is set up by the NSA, so if you don't trust them, don't use Ghidra. And Binary Ninja doesn't have a lot of features, so they all kind of suck, but they're all getting better. Except for IDA, but it sucks because it's expensive. Essentially what it does is it'll take that C code, and I can open up an example actually. It'll take whatever binary you give it, and it'll read the assembly of what's the processor is actually looking at, and then it'll try to turn that assembly back into C or C++.
Wait, so would knowing assembly help you a lot?
Yes. And assembly really isn't the hardest thing to learn. If you've taken your computer architecture class and learned MIPS, that's a really good starting point. If not, it's still pretty doable to learn just in a couple of days.
Right, there's multiple kinds of assembly.
Yeah. So assembly, for those that don't know, is processor dependent. So an Intel or an AMD chip, they're always going to use something called ARM, or not ARM, they're always going to use something called x86 or AMD 64, which is, you can think of as like a language. A ARM chip that your phone runs, that's going to be running ARM, and then like very old stuff like an MP3 player or a PlayStation 1, that's going to be running MIPS. No one uses MIPS anymore. That's why I'm upset that our computer architecture class still teaches it. I get that it's easy, but they should just bite the bullet and teach ARM because it's used by a lot more things. Okay.
What's the processor? You look up the processor and it'll tell you what kind of assembly.
Yep, exactly. So if you look up the processor and you know what processor is being used for a program or the device, then on the spec sheet somewhere it'll just tell you what assembly it uses. For the majority of challenges in CTFs, you can assume that it's going to be an x86 like Intel type of challenge. Sometimes they'll give you an ARM one, but I've never seen a MIPS one. Might be an interesting one to write actually. Okay, so I have this C function, or it's called game. I don't actually know what it does because it's just a random program I had that I opened. And this is the assembly on the left pane. And on the right pane, if I go into functions and pick a function, so we'll call main, it'll try its best to turn this assembly back into C. Now, it doesn't know the names of all the variables and it loses a lot of the context, but you can just rename that. Int input is something that I renamed. It was probably called something else. And you can start to look at this and read it to understand and find out what the program does. So this is Ghidra. It's a very useful tool if you're looking to get into reverse engineering. We'll do a quick example. Yeah, we have time. We'll do a quick example. Can't remember what my example was. Unless I didn't have one. Let's check my notes. Oh, I did have an example. So let's go into our demo. And I have this program called Odyssey. This is also a challenge on our CTF that some of you have already solved. Odyssey is a program that is written in Go. And I don't know what it does, but it doesn't matter. Because first thing I said, you always read strings. If I go to strings and type in Odyssey, I get a bunch of crap. Okay, I know the flag is going to have text on it, so I can do strings and Odyssey and then pipe it into grep, which is a search command, and search text saw. Oh, there it is. There's our flag. So we didn't even have to know what that program does. We can just find our flag by typing strings. So that's why strings is a very, very good tool to always try first. Any questions on reverse engineering before I move on to the next topic?
Wait, so that flag thing, is that the same for everything, or?
So that flag that I showed you, if you go into our CTF and go to the challenge at Go Odyssey, that is the flag for that challenge that you would enter there. Yep. So typically when you have a challenge, you're looking for the name of the, I probably should have put this in the slides. You're looking for the name of the challenge or the CTF. It'll almost always be the same for every question. And then there's going to be brackets and then a random flag inside of that you're looking for. And that's how you know that you've completed the challenge if you find something that's like this. All right.
So you just need to see it, just find it and see it.
If you can copy and paste it, you've won. Yep. All right, next challenge is, or next type of challenges are poem or binary exploitation. This is taking reverse engineering and adding it an extra layer to it, where instead of just trying to understand what the program does, the program that you're given has a vulnerability in it, and you need to write an exploit to take over that program. These are my favorite. They're a lot of fun, but they're also probably the most challenging and take the most fundamental knowledge. So a lot of types of exploits challenges that you're going to see are buffer overflows, where a buffer is accepting more input than memory is actually allocated for it. There's string formats, which is when you can use printf in really weird ways to change memory as you please. And then heap overflows, which are really complicated, and I don't want to get into it. But there's different flavors of all those types of exploits, but those are the main exploits you'll see in these types of challenges. And then the fun is like writing the exploit and figuring out exactly how to get what you want out of the program. So again, you're going to be using tools such as GDB and Ghidra, except there's an add-on you can take to GDB, either Gef or PwnDGB. For anyone that's worked with GDB, it was made in like the 70s or the 60s or whatever, probably the early 80s, late 70s, and it's woefully ugly. It sucks to work with. So everyone in the world decided, let's make it not terrible. And there's a lot of different implementations that make it not terrible. Big one that I like is PwnDGB, which I'll show you right now. So if I were to look at our program, what's the program called? Did I do a make for this? I didn't. Dang. Oh, I do have a make. Cool. All right, so if I were to GDB wrap, I broke it. Okay, you're not working. GDB./wrap flow. Okay, this is a program, wrap flow. If I were to GDB it, then I get pop-up. I can set a breakpoint at main by typing b main, and then if I run the program, It's going to give me a whole bunch of information that probably looks really scary, but it's super cool when you start to figure out how it works. So if we go, oops, if we go all, I'm not in TMUX, aren't I? Okay, if you go all the way up to the top, here's where we ran the program, starting the program, yada yada, and then it gives us registers. So if you've taken your computer architecture class, here's all the registers and what is being stored in it currently. It also gives us the assembly of the program, so we can look at it and step through each instruction and see where we're at in each instruction. You'll see green, it keeps moving down every time you type next instruction. And then also shows what the stack is, so you can see what memory is being stored on the stack, where it's being stored at. And last, it tells you where you're at in the backtrace, which is essentially all the functions that are being called and which function called what. So that's PwnGDB, or DGB. Makes it a lot easier to look through a program while it's running to understand what's going on. And then Ghidra, you also already, is another main tool. Where is... Cool. If you're wanting... Once you get to the point where you want to write your own exploit, PwnTools is the go-to tool. There used to be a lot of different ways to do it. But someone wrote a really nice Python library, and now everyone does that because it's very nice. But you can always write your own exploits in C or Perl. A lot of people used to use Perl. But PwnTools essentially is a nice wrapper around sockets, which provides a bunch of functionality to send data and receive data from a program, be it over the web or on your own device. If you want to learn more about these types of challenges, a really good course, I guess, is called Pwn College. It's put on by ASU's, one of their professors, every year, and he hosts a Discord, open source every lecture on a website, and places all of the challenges on that website as well. So you can do it at your own pace, you can watch all of the lectures, you can join the Discord that anyone can join and ask for help. It's a really good way to learn how to do this. It is very hard and challenging, and there is a lot of challenges to do to get through all of it, but if you're interested, I think that's the best way. Besides that, if you're getting to your junior or senior level courses or a master's student, take any of Dr. G's courses. So in the spring, he teaches a section of CS 4301 called the Cyber Attack and Defense Lab, which is essentially a course of just doing these types of questions, and it's really fun. That's how I got into it. Or if you're in a master's program, every fall he teaches a system security course, and essentially the first half of that course are these types of questions, also very fun. Any question? Oh, let's do a demo actually. So I showed y'all wrap flow. We know how to reverse engineer already, or we're eventually will, so I won't make y'all reverse engineer it. Instead, we'll look at the C code. And see if we can find what the vulnerability is. Looking at that code, looks big enough, hopefully. Can anyone immediately guess what the vulnerability is in this program? All right, no problem. Ooh, someone. I hear a voice.
Is it the gets function?
Yes, it is gets.
Because it only takes a certain amount of characters, I believe.
Pretty close. So gets is a function that takes in user input and places it into a buffer. The only issue is it doesn't check how much user input it takes in. So say we have a buffer. Is there a marker up here? Does it work? It does. So say we have a car star buffer that has 16 bytes allocated to it. That means inside of memory there are 16 There are 16 bytes. I guess that'd be 15. There are 16 bytes that are allocated into it, and then there's going to be other data that is on top and below it. However, with gets, it doesn't check to make sure there's only 16, so you can literally write as much as you want. So a better visual for that would be this right here. We have 8 bytes for a username. However, gets lets us write 2 bytes or even more over this username, which allows us to write anything below this on our stack to whatever we want, which is really bad because below this on the stack is how the program knows what piece of code is going to run next, which means you can overwrite what piece of code is going to run next and say, hey, instead of that piece of code, let's run this piece of code. And you've taken control of the program. You can run whatever you want on that program. Like, hey, give me root access to this computer, please. And then it'll give you root access to the computer. Very cool, very fun. We're going to do a slightly simpler buffer overflow where if you look at the C program, what it does is it has this integer set to the value hex dead beef. And it's going to take input, and then before it closes the program, it's going to see if our integer is still equal to dead beef. So you know how I was talking about how like the line of code that tells us where to go next is located in memory? Well, variables that you assign in the C code are also going to be located somewhere in this memory. So we have our flow. Sorry, I don't know if everyone can see that. We have our flow also beneath this buffer that we created. So all we have to do to get the program to call system cat flag is to get it to overwrite this variable by putting in way too many numbers or way too many letters until it changes. Sounds pretty easy, right? And it is. You can do it. We have a buffer of 512, so the easiest way to do it would be just to run wrapflow and type in a bunch of A's, but I don't want to wait on that. So instead, we'll code it. I already have a solution for you, which will make it easier. If it would. All right, so there's our solution. We're going to use Pwn tools, which I talked about earlier. We're going to import it, and then we're going to set our target to be the file wrapflow, which is the executable. We're going to open that file using elf, and then we're going to run it using process. And then we're going to create our payload, which is the data we're going to send when it asks for data. We're just going to type in 540 A's. That should do the trick. And then we're going to wait until it asks us to get input, which is our receive and tell. Then we're going to send the 540 A's and try to open a shell. So if we run this program, Python solution, we should see some stuff. It's paused. All right, we got it started. And it just gives us the flag. And the reason why it gave us the flag is if we look at the code again, we'll see that if dead beef changes, then it cats the flag. So we overwrote the variable that there was no way to override it in the program because it was on the stack and we could write arbitrary data into the stack. Now that's a lot. If you want to learn more about it, again, take the classes, use the resources, ask me, and I'll be happy to explain it in more detail. But I think it's a really cool demo that a insecure program lets you overwrite whatever you want inside the program. This could be a really important number. It could be a bank account number, and you can overwrite it and set it to 1 billion. That'd be pretty cool. It would also be really bad for the bank. So if you find this and you're a cybersecurity professional, you feel like, hey, someone can do this, and then you're out of a lot of money, which means that they have to listen to you, and you're going to be a super good cybersecurity person. Yeah. Any questions about Pwn before we move on? Excellent. All right. I got 2 more to talk about, and then a couple of closing notes. So this is one of the more entertaining ones. I also think it's a little easier to get into is forensics. It's not like CSI Miami forensics where you're casing a crime scene. It's a digital forensics where you could still be casing a crime scene, but the crime scene is on a computer or on a computer network. So there's 2 main types of forensics, and then there's like the weird stepchild, which is steganography. So the main types are going to be host forensics and network forensics. You can think of host forensics as you have a device, it has some sort of file on it that's doing something weird, and you need to extract information from it. In CTF world, a lot of these challenges are like, here's a PDF, here's a docx, here's an image. Try to get some flag out of it. It's doing something weird. Especially with PDFs, because I found out this summer you can write JavaScript into a PDF and just have it do weird things. Don't trust your PDFs because they can execute JavaScript at will. Really cool. But those are different types of host forensics questions. Then there's also network forensic questions where you're given a network or a network capture of all the data that's being sent over a link on the network, and you're said, there's something in this traffic that we need you to analyze and extract for us to get us the flag or to give us this information. And then last, there's steganography, which is the practice of hiding data in plain sight. So you can think of a picture that has a secret code sent into it, or if you look at it funny and turn it sideways and flip it around, there's a text there. There's a lot of different ways of hiding things in plain sight, and that's what steganography is all about. The tools for the different types of forensics have some overlap, especially between host and steganography. But the big one for network is going to be Wireshark. Wireshark is a tool that will take a network capture and it will understand all the bytes that are being sent between these computers and tell you what traffic is being sent. So when you send a message between two computers, it's going to always use some sort of protocol. Sometimes it's custom written, but most of the time it's going to be a very common protocol such as HTTP, which is what websites use, or FTP, which is what file transfer servers use, or so on. There's a lot of different protocols, and Wireshark 90% of the time will understand what that protocol is. And if it doesn't understand that protocol, it'll say, okay, I don't understand the main protocol, but here's the protocols that protocol used. That might have been complicated. I should not go into that. Other tools are binwalk. What binwalk does is it's a command line tool that will look at a file that you give it, and it'll look for any magic headers. So when you think of a PFD or a PDF, when you think of a document or a lot of other files such as a JPEG or a TIFF, all of those files are going to have something called magic bytes, which essentially is a, hey, I'm this type of file. This is, look for these bytes and you'll know I'm this type of file. And binwalk will go through any file you give it and look for all those magic bytes and say, hey, even though this program presents itself as an image, it actually has a zip file located in it, which has a docx and a couple other images that you can look at, which is really cool because if someone's trying to hide data inside of other files, it's a way to extract that data outside and look at the original data. Other tools are EXIF. EXIF will let you look at the metadata of images, and then hex editor. Sometimes it's good to go into the hex level and try to see exactly what's going on in the format that you're looking at. And last is StegSolve, which is a tool that's used to help solve steganography image type of challenges. Oh, I gotta do a demo actually. I have a cool demo. This is also a question for one of the CTFs. I think it's the easiest one in forensics, maybe the second easiest one. So this is a network forensics question. If we look at it, we're given a Wireshark PCAP, or packet capture, and it looks like it has DNS, HTTP, TCP, and that's pretty much it. So HTTP immediately comes to my mind of what I want to look at because it's going to show me website stuff. Let's look at the bottom one because it's a text HTTP. It's a 200, which means that it's like a response whenever you ask for a website. 200 returns it back. And we can actually look at the code of whatever that website the data was looking at. And it looks like it's running a script, post requests, and some sort of password. So let's see if there was a post request that was made in another packet. Well, let's look a little bit ahead. Oh, we found it. Someone entered their password, and this website didn't encrypt it when it sent it over the network, which is very insecure, and we're just able to get that password for free by having this network capture. There's your flag. Pretty simple. Any questions about forensics before we move on? Cool. Next topic, and this one's also very fun. How many of y'all are on YouTube and watch that one guy that can just guess from a picture exactly where it is in the world? Yeah, Rainbow on GeoGuessr. Yeah. Well, OSINT is kind of like that. In the CTF we competed in this last weekend, one of the questions was a picture of a plane, and it's asked us to find the name of that exact plane. I didn't solve it. I don't think we solved it in general, but apparently it was a really fun one. Those are the type of questions that you get into open source intelligence, where the goal is to take information that is readily available to you on the internet by Googling or other tools, and then being able to get some sort of information out of it that you're looking for. I'm not super familiar with these type of questions because it's pretty new in CTFs. It's really come around in the last 3 or 4 years, and I've never competed in them much. But the main tools to look at when you're starting is Google Foo. Google Foo is just a term of like being good at Google. There's a lot of techniques that you can learn to get better at your Google searches. I'm certain there's plenty of videos and websites online that will teach you how to get better at Googling. Metadata is also another thing to look at. So if they give you a file or if they give you something, you can see if there's any metadata attached to it that might give you extra information on like the artist's name or whatever is available in that metadata, the date it was taken. If they give you an image, you can reverse image search it. This is a pretty common technique that I've seen. And you just see if anything comes up on the internet. And then last, there's the OSINT framework that I discovered today. Super cool. You can say, I have a challenge that I'm working on, and I need to find IP addresses, and they need to be IPv4 addresses. Here's a bunch of tools that'll help you do that. And you can just do that for anything. Username. I need a username search engine. I have an idea of a username. I have a username for one account. Let's see if they're on other accounts. You can use a username search engine. There's a bunch of different tools for a bunch of different things that you might need. And this will be a good starting point to tell you what tools to start looking at and what you might need. And again, that's osintframework.com. I'll post the slides afterwards. I do have a demo for this as well. Again, this is a CTF challenge from our question, or from our website if you're trying to get a free challenge. So if I go down to miscellaneous, no, did we create? We did create it. And I go to OSINT, do OSINT geolocation. I did not upload the video. Who solved this without the video? It's probably someone that did last year. Okay, I'm not doing the demo because I don't have the video, but essentially it's a video that one of our students took going down a street near campus. If you pause it at the right frame, you'll see you'll be able to see the street sign, which then you can use to get the exact name of the street and put it into the flag. I will try to fix this tonight so that you can try it yourself. But this one should be working, and this one's also pretty fun. You're given a image, and you're asked to look it up and find the date that the sculpture of this image when he created his YouTube channel. All right, any questions before we move on from OSINT? All right. So, a couple more things before we conclude. When you're looking for a CTF compete in, there's a couple of different things you can do. First one, of course, is you can do CSG CTFs with us. You can attend on the Saturdays that we open up the lab, or you can just go to our website and try the questions that we have posted for you, and we'll be willing to help out with that and give you any necessary resources in the Discord. Besides that, if you're looking for CTFs that are very beginner-oriented and are always running, so you don't have to spend a whole weekend on one CTF, these are the three that I always suggest. There's others that other officers will suggest, but these are three to start with. The first one is Pico CTF. This is put on by Carnegie Mellon, and it is essentially a very general CTF that contains all the types of questions that I talked about earlier. And they host their competition for like a week once a year, but they keep their questions running throughout the entire year for all their past events as well. So you can just sign up for Pico CTF, log in, try their challenges, and if you get stuck, which is very normal, you can just Google the challenge and see if you can get some hints, or read how other people solved it and try to implement it yourself. It's a very good way to start learning just by doing these challenges. Another one that I always like to suggest is called Over the Wire Bandit. So this is a CTF that is hosted forever. It's pretty old, but it's good if you're not super familiar with Linux and all the ways it works and want to get more into how Linux works in the command line. The very first challenge is actually going to ask you to connect to a Linux machine over SSH. And then every other challenge after that will be using that SSH connection that you learned about earlier. What I really like about this one is it gives you commands you might need. It also gives you links and resources that might be good to read up on for the challenge. Sometimes they're deceiving because they're not used until like a couple challenges later, but it's a really good way to learn more about A, Linux, and B, the CTF structure. And then the last one that I suggest is TryHackMe. So TryHackMe is less of a CTF and more of a learning platform for security. But they have a bunch of boxes that in like little courses that are oftentimes free. Sometimes they're not free, but it's like a $10 a month subscription where you can just learn different topics. They have paths for you to look at. They just have random boxes you can look at. So if you want to learn more about OSINT, try the OSINT box. If you want to learn more, I don't know, this is a blog that you can hack. That's a web challenge for you. Eternal Blue, that's the one we did at our kickoff. So there's a lot of different challenges. There's also like learning paths for you to practice that'll help you improve your general CTF skills and your general cybersecurity skills. So like red teaming, cyber defense, pre-security, a ton of stuff. So not all of it's free, but they do have free stuff. Besides that, if you're looking for CTFs and actually wanting to compete, you can just go to CTF Time and go to their upcoming and just see what's going on. Typically, you're going to want to pick ones with a kind of a low weight. 100, that essentially means that this is going to be one of the hardest CTFs this year. Don't do that. If you've never done a CTF, you're going to hate yourself. 25 or I like to do anywhere between 25 to 40 for beginners. If you see 0, all that means is this is the first year that they've hosted a CTF, so you don't have a score point on it, but typically it's going to be more beginner friendly if you see 0. So just pick one that fits in your schedule. Wait for it to start. They'll probably have Discord and a website on here as well. And just create an account and try some challenges. Don't be afraid. It's pretty simple to get into, and it's just try to solve 1 or 2 questions whenever you get a chance. All right. Last slide are some general tips that I didn't know where to put elsewhere, so I'm putting them here. The first thing that I suggest to everyone is to spend some time learning your fundamentals. You're not going to be a security wizard overnight, and if you're trying to skip straight to super complicated stuff, then you're going to find yourself very frustrated because you're going to be lacking some prior knowledge. Now, don't take this as me saying you have to start with perfecting networks and discrete math and computer architecture, because no, you don't need to know everything about those topics. Rather, it's just good to have an understanding of those topics that you can build upon, even if it's something that's super minor, because you'll always be learning more stuff about whatever topic you're learning about. Besides that, when you're looking for CTFs or you're looking for challenges to do, you want to find the sweet spot. You don't want to just pick the easiest challenges that you know how to do and only solve those. And you also don't want to be banging your head on one problem for 48 hours. If something gets too hard, too tedious, take a break, try another challenge, come back to it if you have an idea on how to proceed from there, or just wait until the end of the challenge ends and look up how it's solved after that. It's important that you challenge yourself while also providing yourself like that boost of serotonin whenever you solve a challenge. Next, whenever you are participating in an event, it's very, very helpful if you're in that Discord channel or their IRC channel that they're hosting. Oftentimes you'll get notices that, hey, this problem is broken, and oh, I was working on that problem. Now I can stop banging my head because it's not my fault. Hey, they'll just provide details. Don't be the guy that's asking for answers because no one's going to give you answers. But after the challenge is over, then you can say, hey, I was working on this problem. How was it solved? Because I didn't figure out how to solve it. Also understand that when you start your CTF journey, you're not going to be that good. That's just a fact of life. When you start anything, you're not going to be that good. It just takes time. It takes practice. Set realistic goals and understand that what you're doing is you're building a career that'll last a lifetime. On top of that, I'd like to add this little YouTube video that's 1 minute by Live Overflow.
Maybe you think there's some kind of shortcut, or at least a very efficient path. You hope a professional or experienced person can easily tell you about a clear path to success. I certainly had exactly those thoughts several years ago. I got frustrated why nobody would write down a clear guide. I felt somewhat entitled that I have a good experience already, I just need some guidance or mentoring. But the truth is, there is no efficient path. Truth is, it just takes years of experience. So if you think that somehow it would be easier with a study plan, it's not, so forget it. I'm sure you know this interview question. What advice would you give your younger self? And for me, I don't know. While certainly thinking differently at the time, in retrospect, I don't think there was anything bad or inefficient about the path I took. Of course, I could help my younger self understand certain concepts better and faster, and that's what I try to do with the videos. The videos cover exactly what I would tell my past self, but I couldn't lay out a path of do X, Y, and then Z. There is no secret step-by-step guide. It's not a straight path, but a web of interconnected topics, layers, and dependencies, and you're free to walk and jump between stuff however you want. Truth is, anything you do, any tutorial you follow, any project you start and never finish, any dead end you head down, it's not wasted. It's all experience that is accumulating over time. If I learned anything about hacking, what it means, what it is, then, at least to me, it's not really something I can get a hold on. It's an abstract, artistic, and broad term for many different things. Truth is, hacking is just learning IT stuff, but kinda in an artistic, weird, creative way.
Alright, you can watch the rest of that video on your own time, but I think it's a very good kind of way of framing your journey through cybersecurity in general. And then last things I'd like to talk about is when you are competing these CTFs and they finish, read some write-ups. So if you go to CTF time, and we can actually do this for the last CTF we competed in, we can look at people's solutions to challenges that are in the event by just going to write-ups. And you can see, okay, this team wrote it for this task at this event. Here's Patriot CTF. Let's look at people's write-ups for Patriot CTF, event task and write-up. Looks like there is 4 or 5 right now. You can just open this up. Looks like they posted a link to it. There it is. And here's the solution. So I got stuck on Capybara. How did I solve this? Let's learn how to solve it by reading how someone else solved it. This is I think the most crucial step to learning and getting better at your cybersecurity skills, because oftentimes you will fail and you will not know how to solve something, which means if you just kind of drop it and leave it there, you might have learned a little bit, but you're not learning the full extent of what you could learn by going back a couple days later when someone tells you how they solved it and learning from others and gaining that experience logging it in the back of your mind and saying, all right, next time I have a challenge like this, now I know what to do and I understand how to solve it. So that concludes my talk. Don't be afraid to fail. Read and write your own CTF write-ups. Any questions? Excellent. I want to thank you all for coming. We're going to meet next Wednesday. Don't know what the talk is, but it will happen. Pizza as always. Have a good night.